Okay, we're going to start with a little bit of top 20. These three problems, I'm factoring the top there, and now I'm going to factor the bottom. It always starts with an x. And in this case, who's got it? X plus, yes? All right, if you didn't know that, you have to ask yourself, am I really serious about making it in this honors class? Because that's a basic you should know, and if you don't know it, it doesn't make you a bad person, but if you don't take the time to figure it out after I've warned you like 17 times, and I've given you videos you could use to do it, that means you're not taking this class really seriously, okay? Go learn how to do that. I've got videos for that at davidserver.com. Go and do it. Those cancel. X minus 5 over x plus 1 is the final answer. You can't cancel stuff until you get it to be factored. Let me show you what I mean. If I had this, do you get you cannot cancel those 5s? Otherwise, 6 over 5 would be equal to 1. It's not. Okay? You can't cancel those 5s. Why? Because it's part of a plus problem. Can you cancel 5s when they're in a multiply problem? Absolutely. That would be 7/4. You know what I'm saying? You need to make stuff into a multiply problem before you can cancel. So that's why we factored it. And that's why that's the final answer. X minus 5 over x plus 1. All right. Do you get that this next one would have been incredibly easy if I'd have just said 2 times all that? You just distributed the 2, right? 2 times x squared, 2 times the 2x, and 2 times the 3. Well, that's half of the problem. If you're going to do this one, first I would start by multiplying everything by 2. And then I could multiply everything by x. So this x has to also get multiplied by all 3 parts. Okay, when I actually do that, I'll write out all the parts. So that one, the x, it doesn't matter which one I do first. I'll do the x first. X to the third plus 2x squared plus 3x. Then I'm going to do this 2. And that's going to be 2x squared. I should really line that up with the other 2x squared, shouldn't I? You don't have to. Just way to keep it like lined up. 2 times the 2x is plus 4x, and 2 times the 3 makes 6. Add it all together, final answer. This is where the rubber meets the road. X to the third plus 4x squared plus 7x plus 6. Raise your hand if you had that one right. Awesome. That's way more than normal. You're in a very smart class right now. You should be happy about that. All right, on to this one. Hint. Every top 20 has got about 2 things in it, which really makes it the top 40. It just would sound too intimidating if I said that. Each question has got 2 parts. Like this one, you can't do this question unless you know how to both simplify that part and factor the top. It's got 2 parts. It's got a factoring part and it's got a simplifying part. If you don't know either one, you can't do it. So it's kind of the top 40 once you got this all figured out. All right, that. Square root of 9, square root of 3. Same as 3 root 3. How many of you knew that part? That's the easier part. Now here's the factoring part. 3 plus and minus that all over 12. How do I factor that? Well, 12 is easy to factor. It's 3 times 4. Why did I do that? Because you got to make it into a multiply problem before you can cancel stuff. I cannot cancel these 3's. That's not legal. Why? It's part of a plus problem. It's not part of a multiply problem. Yes, sir?
Can you cancel the 3 that's decimal plus 3?
Good question. Because it's part of an add problem and a times problem? Nope, I can't. It has to just be separated off, and I'll show you in a moment that I can cancel it, but only after it's been factored. Let me show you what I mean. That now can factor into 3 times all over 3 times 4. I want to see, there's usually, again, a subset of kids that can't get from here to here. See if you're one that knows how to factor that. Even if you got lost earlier, do it from there. I need to know who can do that. Miss M, I think you can do that. Wait a minute, where'd you get the 1, first of all? You're right. Just to clarify, you're right, but where'd you get it from? If you take a 3 away, a lot of kids think that if you take the 3 away, it'll be just gone and there should be nothing there. But you did it right, and you said there's a 1 there. Yes, you can say you divide it by 3. I love that. Option B, instead of saying you divided it by 3 and that left you a 1, is you could say this. Would you agree that even a 3 can be factored into 1 times 3? That way, when you pull the 3 out, you see you still have a 1 left. A lot of people think there's nothing here, but there's a 1. Okay, finish it. You were right. Square root of 3. All right, now it's factored. Why is that so special? Because once things are factored, they're all primed and ready to cancel. Cancel, cancel. And there's my answer. 1 plus and minus the square root of 3 all over 4. And I hope you get that's 2 answers in one. One's with the plus and one's with the minus. There is no such thing as adding and subtracting at the same time. It's just one of the answers has a plus in it, and the other answer has a minus in it, and you can make your life simple by writing it once instead of twice. All right. How many of you actually had that before I explained it? And again, that's about half of you. All right, the rest of you guys need to learn how to do that. All right, there's a app for that. You know, that's what Top 20 is for. There's videos for it. There's extra practice problems. There's version 5 still sitting out there waiting for you. Version 4 was due today, I think, wasn't it? Or okay, but I'm not creating it today because I riffed for, I intended to riff on the survival thing after watching some videos about how rough it is right now in Puerto Rico. So, all right. Now we got to get into the new stuff. Everybody find the file that's got today's date on it, 9-25. I'll pause while you pull that up. Okay, there's only one function missing, and I drew it in for you. These are the 5 big ones, plus I drew in that one. You remember the circle? All right, we practiced those on Friday. You got to be good at them. And today, I just have to teach you a little bit about how to move them around. All right. Here is a function. You should be able to, from the other day, be able to say, oh, I remember what that looks like. Remember what that looks like? That's the one that looks like this. But what if I wanted to move it? What if I didn't want it to be there? Functions can't just always stay there. Usually you're writing a function to model a real-world situation. And you might say, well, in the real world, my ramp starts up about 3 feet because, you know, it just, I don't know, maybe it needs to be up a little higher, so you moved it up. How do you move this thing up 3 feet? Well, we got to put a 3 somewhere, obviously. There's 2 choices I would see as logical. One in there or one out there. Only one of them works. Here's a way to remember. If it's inside with the X, it'll be horizontal on the inside. If it's outside, it'll be a vertical move. Like if I put the 3 out here, which is the right answer. Nice job, those of you that guessed that. That's a vertical on the outside. High-vo. It's like the 7 dwarves in, what's that one with the what? What? Snow White, there we go. Snow White and the 7 dwarfs. They would sing hi-ho, hi-ho. It's off to work we go. Anyway, if you haven't seen it, you've missed a small part of your childhood. You got to go back and watch it. That's Snow White. Her 7 dwarfs told you, hi-vo, hi-vo. It's horizontal on the inside and what on the outside? Vertical on the outside. Dumb little things like that will stick in your head. So when you're on the test and you're going, okay, let's see. He's given me this. And I know it's a parabola because it's got that squared on it, but I can't remember if the 7 is the up or if that's the left and right. Oh yeah, it's horizontal on the inside. High-vo. So it's a horizontal move on the inside, and it's a vertical move on the outside. So where do you think this parabola goes? I agree, it moves down 8. And then how about on the plus 7 thing? It seems like it should be to the right, But you remember me saying it would be the opposite of what you would expect? It actually goes to the left 7. All right. Now, you can't trust the stuff on the inside. It always does the opposite of what you'd expect. I got a great story about that. You got to remind me to tell you tomorrow when I have more time. You can't trust the stuff on the inside. I had a friend who was in jail. He was on the inside. That's what they called it when he was in jail. It was really interesting because I never actually met anybody until my friend that had been to jail, and he told me all kinds of interesting stories about what that's like. So, anyway, the high vo is reminding you that it's horizontal on the inside. I'm reminding you that it's opposite of what you'd think. That should say to you, where's 7 on the x? It's over there. Why didn't I move it over there? Because it's the opposite of what you'd expect. Stuff on the inside goes the opposite way. All right, so all you are going to have to do is be able to say, here's my graph, and then the domain and range of it. All right, so just a reminder of what domain and range are. If I was going to pick that point right there, it would be kind of important. It went 7 to the left, so that's -7, comma. It went down 8, -8. -7, -8 down there. I know that's not perfectly graphed, and it's okay. Now, what's the domain of it? The domain is how far does it go this way? That's the domain question. How far does it go as far as x goes? If I extended this forever, it goes from -infinity to +infinity, and that's how you'd write it. And the range of this graph is the up-down. It's like this way. How low does it go? It goes as low as, now is it -7 tell you how low, or does -8 tell you how low? -8. And then how high does it go? Infinity, and then one last thing. It touches at -8, so it would be a bracket right there. All right, so you're going to move your functions and then tell their domain and range. That's a typical question for today. All right, let's zoom through a bunch of slides. I'm going to pause for a second while I do. Okay, so let's say we had this one, and we had square root of x. I wish it was just the square root. It would just look like that. But this is pretty simple. I just take the square root and move it where? Down 4. 1, 2, 3, 4. There. You get how easy it is once you graph the parent one? Now you might be saying, well, you just kind of slopped the parent one up there. I want to be more accurate. Okay, cool. Here's over 4 up 2, over 9 up 3. Would you agree that those are all points that are square roots? Okay. Then I take each of those points and move them where? Down 4. 1, 2, 3, 4. There's a very accurate answer, which I should connect with a line because there's stuff in between them. It's not like it's distinct individual little points. It's got everything in between. And it goes forever that way. And then on the more advanced questions, they would say, and what's its domain and range? And the domain on this would be from 0 to infinity. And the range on it would be, starts here and only goes up from there, right? So it would be, domain was 0 to infinity, can touch 0. Range would have been from -4 to infinity, and it can touch -4. There. That's a typical highest level question for today. All right, let's, oh wait, this one? Remember the high vo thing? What does the high tell you? Horizontal on inside. That's on the inside, so it's a horizontal move. And I told you not to trust the stuff on the inside. So it says -4, which feels like it should be to the left. So it's actually to the right. Okay, good. All right, your assignment when you get there is right here. It is a worksheet. It's a PDF. And given that I'm not giving you that much time to work on it today, in some of the hours it was much worse. They had almost no time. I gave the evens only on this worksheet. And I also said if there's a question that is an even, but has lots of parts, like A, B, C, D, E, F, G, okay, you may just do the even letters. And what is an even letter? Think about it. B, D, F. Get an idea there? All right. So if you had problem 1 that has a whole bunch of parts, that's a whole different question. It would be great if you did the evens on those 2, but if it's an even, you remember I said evens, You really only have to do the even problems. And if any of the evens, I don't want to like hurt you by like problem 2 had like 73 parts. If I really want to cut it down, then I should say on problem 2 then, you can just do the even parts of it, which would be the even letters. All right, that keeps it down to a very reasonable size. Some of them are graph. Remember, your best friend on graphing is the XY chart. If I couldn't remember what this parent graph looked like, you can always use this. It helps a lot. You go, I can't think of any points on this thing. We'll stick in 0 and see what you get. -4 plus the square root of 0, that would be -4. I know the point 0, -4 is on this graph, and I can just keep graphing points until I figure it out. And then if I start seeing it, and I'm like, oh, there it is. It's the square root. It's just been moved or whatever. You find it by just finding a bunch of points. Okay, that's all I got for you for today.